All right, so we're going to talk about Fan Energy Index, FEI. My name's Tony Mormino. I'm the marketing director for Insight Partners, and thank you so much for coming out today. So just a little bit about the show today. If you get your name tag signed by 15 vendors, trailers, et cetera, 15 folks that are showing, you get to enter the raffle for the green egg and the coolers. Did you all see all those prizes up there? Okay, so we greatly appreciate it if you can go do that. Just take a few minutes and walk around. We appreciate it. Okay, so Fan Energy Index. So this presentation was provided to us by our manufacturer, GreenHeck. So I want to recognize them as the contributors to this presentation. Good morning. Come on in. So FEI, Fan Energy Index, who's heard of it? Oh, so a lot of you have. Okay, good. So you might know more, you might know more than I do about it. But we're going to talk about what it is. We're going to look at some fan system selections. We're going to talk about the code adoption, and then we'll go over compliance and recommendations, okay? So I'd love to get your feedback on how you're using it, how you're scheduling it, and as we go through the presentation, if you got some tips and notes on that, that would be great. Okay, so what is FEI? So it's a ratio that allows you to easily compare different fan systems with each other. Okay, it's 1.0 typically or greater if it's efficient. It can be less than that. It's a tool that helps you select the best fan. It's not just an energy efficiency deal. It actually puts you in a place on the curve which has stable operation, low acoustics, and gives you some flexibility if the static's different than what you designed for, which I know never happens, right? Ever happens. And then we're going to talk about the mandate, which is coming in 2019. So at some point, it's going to be mandated, and all the manufacturers have to comply with it. But the purpose of this presentation is to kind of raise awareness to it. You might want to think about starting to specify Fan Energy Index if you're not already, and maybe start doing it at a level that'll keep you safe depending on what state the fans go into, et cetera. Make sense? Okay, so what is FEI? So what FEI does is it takes a base electrical input of a fan system. Okay, this is determined by AMCA. And then it looks at your actual electrical input selection from your program. It takes the fan at a specific CFM and static pressure, looks at the energy it takes, and compares it to a baseline electrical input, which we're going to talk about that in a minute. This is a general fan curve that shows the FEI. So you got your airflow versus static pressure. You've got your do not operate in this area, which is called the surge area. Do you know what happens when a fan operates here for a long time? Flies apart. Quarter-inch steel, welded, doesn't matter. Flies apart. So you can see from this fan curve that generally speaking, the more efficient the fan, the better it is located on the curve in terms of efficiency, acoustics, and putting you in a safe area. Okay, it doesn't always mean that the higher FEI is the best fan selection in terms of static pressure and acoustics and stuff like that. So we'll look at a few examples of that. But generally speaking, you want to be in this area. So any questions on that? Okay, FEI of 1.0 would mean that you're as efficient as the baseline. Anything greater than that is 1.1 is a 10% over the baseline. 1.2 is 20%. Okay, so you can take these numbers, this fan's 1.1, this one's 1.2, and you get a quick snapshot of their efficiency. I have to tell you too, this presentation's kind of short, so I'm kind of going to stretch it out a little bit. Question? Can I just ask a question real quick? Yeah. Did anyone drive a blue Nissan SUV? Blue Nissan SUV? Sorry. Nope. There's always a vehicle. Okay, so what were we talking about? Oh, this presentation is kind of short, so I'm going to kind of stretch it out a little bit. I do have some supplementary slides because I want to make sure we fill up the 45 minutes for you guys. So, okay, so what is the base electrical input power? We'll start with that, and then we'll talk about the actual electrical input power of the fan. Okay, so the base is calculated by AMCA. Okay, there's two AMCA standards if you really want to geek out on this stuff. and learn all you want about it. There's AMCA 2008-18, which is the calculation of the fan energy index. And then there's AMCA standard 2014-21, which is the test procedure for calculating fan energy index in commercial buildings. By the way, we're recording this for our YouTube channel, so if you want your brilliant question on YouTube, get it out there. So those are the AMCA standards, okay? Calculated by AMCA. It assumes a belt drive fan, 60 hertz, with a 4-pole motor. Does anybody know the difference between a 4 and a 6-pole motor? I read it for about an hour this weekend, and I still don't know what it means, but.
Well, I mean, electrically, the nominal speed is 1,200 RPM for a 6-pole and 1,800 for a 4-pole, and if you do have 2-pole, it's 3,600. But it's the way, I don't know electrically internally what the difference is.
Well, you taught me something there. So the 4-pole is nominally 1,200?
No, 1,800.
1,800.
And a 6-pole is nominally 1,200 RPM. Meaning
Got it.
If you send at 60 hertz frequency, it'll run at 1,200 RPM. 1,800
Excellent.
and 3,600.
You just gave me my next LinkedIn post. I did not know that. Okay, so belt drive, 4 poles, 60 hertz, and an IE3 efficiency motor. Okay, does everyone know what that is? Does anyone schedule motor efficiencies? Peter, do you see that often?
I see when
Custom units sometimes?
Have, permanent magnet motors, everybody, the new IE5 is sort of the highest efficient.
Ultra premium, yeah.
So IE3 is standard for induction motor. Like that's the premium efficient induction motor efficiency.
Got it. That's what we typically see. So there's IE3, international efficiency, believe that is. I have a slide on that later. So 3 is premium, and then 4 is super premium, and 5 is
what permanent was, and then they improved the efficiencies of permanent magnet
to 5.
IE5 now.
Got it. So this is like 93 to 97%, something like that, efficient. Anyway, so it assumes an IE3 motor. Okay, and for each duty point, there's one baseline number. The top number, there's one number for each duty point, which is a CFM and a static. Okay, so in the AMCA, for every CFM and a static, there's a baseline duty point. Okay. So I think these next 2 slides explain it real well, why it's different than what we're doing today. Okay? So we looked at the baseline. Now let's talk about the actual electric input to a fan. Okay? So when you look at a fan system, you have power coming in, right? You can or may not have a VFD. It may go directly to the motor. So let's say you have a VFD motor, you've got drive losses, belts, bearings, and then the aerodynamic loss or the aerodynamic efficiency of the fan, which is its ability to turn brake horsepower to CFM at a certain static. Okay? So the actual electrical input power takes into account all this. The whole fan, when we talk about fan systems in here, it's referring to that. Okay? So does anyone know where brake horsepower applies in this scenario? I thought it was here at the shaft of the motor. But I've been told it is not. It is here at the shaft of the fan. Okay? So the brake horsepower is an indicator of what's available here to the fan. It doesn't know what's upstream of the fan. Correct. That's the key. Okay? So, a lot of people will say, well, we're scheduling brake horsepower. And I'm like, yeah, that makes sense until I looked at this. So.
Straight from the motor to the shaft, and that's it.
Right. So it's only taking, so you can compare brake horsepower to each other, but it's only taking into account the aerodynamic losses in the bearings. It's not looking at, it doesn't know if you have an EC motor or a IE3 motor. Okay? So this is kind of FEI is not new, but this was different than what we're normally used to scheduling. Okay, so the FEI, fan energy index, if you look at the power in, VFD losses, motor losses, drive losses, bearing losses, aerodynamic losses of the fan. Whereas brake horsepower is just looking here. So it's what they call a wire-to-air measurement, FEI. It's taken into account. When you look at the power coming in to the CFM going out, it's taken all that into account. Make sense? Pretty simple. There you go. Wire-to-air metric. So that's what's new about it. Now, the rating is not new. It's been in 2019, ASHRAE 90.1 for a couple years now, which has been adopted in a few states. I have a slide for that, but I don't think it's been adopted here. Does anyone know what 90.1 standard you're working off of? I think it's 2016, 16. Okay, I'm going to show a slide earlier which has some information on it. If you have an update to that, let me know, and I'll make sure to tell the folks. So, okay, any questions up till now? Pretty straightforward. Okay, so now we'll look at doing some fan selections. Advantages of using FEI versus brake horsepower or any other method is higher FEI equates to higher efficiency, lower energy usage, less carbon, et cetera. They have a forgiving selection point, which means it's in a good place on the curve. It's not too close to the surge line. It's not too far away, which is really inefficient. Could cause acoustical issues. And they're generally quieter. And these are all generalizations. These are not always correct. So, and in submittal review, you can quickly kind of have a one-shot snapshot of different values. And it's kind of all-encompassing value is the way I like to look at it. All right, so now we're going to look at 3 fan systems and the different FEIs and why FEI is different than brake horsepower. So you've got 3 inline fans here. They're all 16 inches. The one in the middle has an EC motor. They're direct drive. Here's a schedule or selection. So 3 similar fans, 16 inches, motor types, induction, EC, and then induction, all at the same CFM, all at the same external static, all have similar sound. Motor horsepower is different, so you have 1.5 versus 2 and 2. That's the nameplate motor horsepower. And then the brake horsepower are all the same. So, which fan is the most efficient? That's the question. And why? So you might look at the brake horsepower, which is what I did, and said they're all the same. They all use the same brake horsepower. Until I looked at the other slide and realized it does not take into account the different motors and the different, if it's direct drive, belt drive, et cetera. Or you might say, this one's got a 1.5, so it's more efficient because it doesn't need the 2. In actuality, somebody said it, number 2 is the most efficient. And the reason that is because of the EC motor. Yeah, EC motors are more efficient. Yeah, they're more efficient than. That's another thing I've read 500 times what how an EC motor works. I just don't. I've been in front of one and had someone explain it to me. I'm like, I still don't get it. That's why I'm not an electrical engineer, that's for sure. I think there's some verbiage on here. Okay, so all 3 fans are aerodynamically identical and have the same brake horsepower. However, each fan has a different motor, and EF1 includes a 6-pole. How many RPM? 30? Nominal 1200. Requires a VFD to hit the operating point. EF3 is a 4-pole and requires a VFD, while EF2 is a high-efficiency EC motor. Okay, so you get the point. Just brake horsepower alone doesn't really give the whole picture. Comments, questions? Got to drag this thing out a little bit. Okay. So is a 1.4 FEI a big deal compared to a 1.28? Okay, so this is just going to go through some calculations. By the way, your favorite selection program should have FEIs built into it, so you don't have to sit down and calculate this stuff. So over 1 year, you're talking about a 534 kW energy difference, and what we're doing is comparing 1.4 to 1.28. $64 in cost over a year and 458 pounds of CO2. 10 years, multiply that by 10. Pretty easy. $640 in cost. You got 10 fans, multiplied by another 10. So 10 fans, 53,400 kW in energy savings. Over 10 years, 6,400. So the difference between there, it does matter a little bit. Gives you something to put your arms around. A lot of CO2 savings. So. All right, so forgiving selection point, we talked about that. How many of you, when you're selecting your fans, really get into fan curves? A couple of you? If you don't do a lot of custom units, you probably don't look at a lot of that, but they're important. The forgiving selection point means a lot because it puts you in an area which, generally speaking, keeps you away from the surge line. Generally speaking, it's more efficient and quieter in this area and more stable. What's your experience with that, Pete?
It's kind of a balance and application dependent because obviously the closer you get to the surge line, the more efficient you're going to run. But
Yep.
you also, once that curve starts flattening out, you don't have a lot of lenience for if you miss your pressure, your external static. But if you select something farther out on the curve, you're usually at a steeper point and therefore can get most of your flow rate, you know, if you need a little bit more static, but you're operating at a lower efficiency. So it's kind of, I don't know.
Well said.
You sort of have to think about what the application is and what, you know, how close you feel you've got in your external static count.
Your confidence in the
Yeah.
in the reality versus what you're selecting for. And you bring up a good point. It's almost like an art. If you gave a custom selection program to 5, account executives, you might get 3 different answers. It really just depends on personal experience. But so the purpose of this is to show you, if you're over in this area, it's a low FEI and it's not a very good place to be on the curve. You generally want to be right in this area. So the point is, if you select the FEI at a higher value, you're going to generally be in a better place on the curve. Okay, so it kind of serves as 2 functions. Not only the efficiency, but a little bit of a safety. If you've got an FEI of 0.7, you might want to check the curve and see where it's at. Okay. We talked about acoustics. So the higher the fan speed, higher the sound generally. The lower the fan, I think I said that backwards. So the FEI, greater FEI is more efficient, which has lower speed and lower sound. That's what I was trying to say. So any fan can meet FEI values if you oversize it and slow it down. It doesn't always mean it's the best selection. Question?
What is the sidewall?
This type of fan? Generally see that like as a ventilation fan in a warehouse or something like that.
What makes it a sidewall?
It literally mounts to the sidewall.
Mounted valve, like a wall mount.
Yeah.
Like a warehouse per color sidewall fan.
You have some louvers on the exterior.
Gotcha. Thanks.
Yeah, no problem. Good question. So greater efficiency, greater FEI, lower speed, lower sound, lower FEI, higher speed, higher sound. So again, it's just showing you that using the FEI is more than just the efficiency, okay? So if you look at the bottom here, You've got the sidewall propeller. You've got a 24-inch fan versus a 36. Same CFM, same external static. So these aren't ducted. That's why they're static so low. Inlet zones, which is the sound value. Motor horsepower size, fan RPM. So this larger fan is spinning at a lower RPM. It has a lower sound, lower brake horsepower, and higher efficiency. Okay. So that's just to show you it can put you in a safe area in terms of acoustics. Okay. So kind of some red flags when you're looking out at selection programs. So you should, do you all see FEI in your fan selection programs? Does anyone here use selection programs, or do they get them from their vendors? Are you seeing the FEIs in the programs? Okay. Yep. So these were put in here as kind of some red flags. So if you're comparing two FEIs, and one seems like, why is this more efficient? It's got an induction motor versus an EC, that's kind of a red flag. Like, so this is a way to check to make sure the FEI is legit in whatever program you're using or when you're looking at a submittal, because if you're comparing one with an EC motor and one with a belt drive that has an induction motor, and they're similar in fan construction, they should have a different FEI. Are they both using the same type of drive, direct versus belt? Are there differences in the motor voltage phase, horsepower, or poles? Are all fan controls like VFDs being included? Is there a different impeller technology? Is it a different type of fan? And did the sound go up? Okay. So that is the end of that section. In general, higher FEI values indicates an overall better fan selection in terms of acoustics, being in a great place, better place on the curve, and efficiency. Any questions on that part? All right, code adoption. Here's kind of where we're at. So we talked about the AMCA standards earlier. This came out in 2017, which defines how the calculation is done and then how to test the fans for the baseline input, electrical input. 90.1, 2019 has adopted this, that it has to be greater than 1.0. Okay. California has something called Title 20. They always got to do something different. I don't know what it means. I think it just means it applies to that. It complies with that. It mirrors 90.1. The important thing is, right now, the DOE is proposing federal FEI regulations across all manufacturers. So the way it's been explained to me is the DOE will put out a sheet with different types of fans and says, this is what we want to do. The purpose of that, in their mind, is to cut off the bottom 25% least efficient products. But what happens is sometimes they overreach and the manufacturers say, if you do that, it's going to eliminate 60% of our products or 40% or whatever, okay? Then they come back and they iterate and they go back and forth. So right now, that's where we're at in terms of the DOE and the regulations that are coming. So in 2029, there'll be federal regulations of FEI. So the manufacturers have to, at that point, can't ship a fan with a FEI lower than whatever they define it to be. Does that make sense? Peter was telling me pumps are doing that right now, right? PEI, has anyone seen that? Pump efficiency index. Okay. It's different, it's backwards. The higher the number in the PEI, the less efficient it is. So isn't that great? So they made it more confusing?
Like standardizing, right?
It's the same department. Did the pump guys not go talk to the fan guys? I mean, what the heck? So, a couple points to this presentation is it's coming, be careful. Some of the states have adopted 2019, okay? So if you look at this, 91 2019 is where it says it has to be over 1.0. Where are we operating? Somebody said, this shows 2010. This could be wrong. I don't know if it's right or not, but we could check that. But I don't think we're at 90. We're at 2019 in North Carolina. Okay? So does anybody do work in any of these green states? Virginia. Do you specify FEI? Has the DOE police come and raided your house yet? I just got off the phone with, I can't say their name because we're in a PDH presentation, but a major manufacturer. And they said that we should be, the engineers are required to be in compliance per the local state codes or something like that. But I don't know how they check it. At some point, the unit's going to ship with a sticker. It says FEI of whatever at this RPM and this static. The T&B guys could actually have to make sure it complies with the state codes at that point. It's going to be a big deal. It's going to be a big deal. So if you specify a unit at 2 inches and sprinkler guy gets there and the duct's got to go a different way and it's 2.5 inches, if that fan is not in a safe enough range, it could go outside the FEI value. Now my response is there's no way people are going to check that, but they said they are actually going to check it. It's going to be a big deal. So the T&B folks will look at the nameplate and they'll compare it.
It's one of those 80,000 IRS engines.
What's that?
It's one of those 80,000 IRS engines.
Yeah, exactly. Come knocking on your door. Middle of the night with SWAT team. So it's confusing. And one of the points here too that I'm supposed to make is like, be safe now, get ahead of the curve, start specifying at least 1.0. When we look at some selections in a minute, if you could select a 1.2 and it's relatively the same cost, go ahead and do that if it's in a safe place on the curve, just for, to make sure you're safe, because this is all gonna change. Any questions on that? Okay. Here's kind of the values that are proposed right now. So you can see, I think we were looking at an inline centrifugal fan earlier. So 1.28 in 5 years. So this is going to change, most likely, is what I was told, but it's coming. So exceptions to the regulation. Fans embedded in equipment that is already regulated. So if you have a packaged DX unit and it has to comply to some EER or SEER, then you don't have to worry about this. So you don't have to worry about double regulations. And in 2029, you don't have to worry about any of it because it'll be the manufacturers that are worried about it. But it will still be a tool to use to get a better fan selection. Ceiling fans are subject to other regulations. I'm not familiar with that, but I guess they are. You can come in, Ermias. Fans used for critical applications such as explosive environments and fans with a motor horsepower less than 1. Okay?
Question, Tom?
Oh, yes, sorry.
So, if you're specifying a package rooftop unit, for example,
Mm-hmm.
is that governed by some other efficiency standard already, or does this apply to that?
Do you know, Peter?
I mean, not other than the refrigeration, just the IER requirements.
Yeah.
Right, the energy code has a whole table for IER.
IER, that's the, yeah.
So it's already regulated by the And so the fans in the box, in the unit are gonna, all that energy is included when the selection gives you the EER or the IER.
Gotcha. So we wouldn't need to ask for an FEI on the fan
No,
package
correct.
or air handling unit.
You can separately call for different motor efficiencies like the IE3, up to IE5 as well, but as far as like regulation standpoint, yeah, there's already that.
Yeah, and I guess you can specify this 20-ton package unit should have an FEI. I don't know if all the manufacturers will have it in their data. That would be the only thing. They might, though. They probably will. Good question. So does anybody know what IECC is? Has anyone ever done a job that complied with that? Okay. So anyway, if you do, it already mirrors the FEI 90.1 2019. So it has the FEI fan stuff in there. So it's kind of like a souped up lead program is what I understand it to be. So nationwide, coming into effect in 2029. So compliance recommendations. 1134. Okay. So this is the recommendations. Start using it. Even if your state hasn't adopted, update your specs now and schedules to include FEI. Is anybody specifying FEI? Gotcha. Use your favorite FEI fan selection program. Use caution when you get VEs. If you specify a 1.2, just be careful. You might want to, if it were me and I was specifying jobs in other states, I would probably just do a 1.0 or greater. It's not hard to meet a 1.0. It's super easy. And if you care about the fan curve, you're probably going to be greater than 1.0 anyway. Hold your schedules to, the duty points for the FEI. So how to use the fan? How to use the FEI in fan selections? Pick your fan for your application and run the selection. And then compare the FEI values and the fan curves, et cetera. Call Peter, he'll do it for you. Anytime, day or night, right? That's right. Okay, so a sample schedule. I know no one in here has ever seen a fan schedule, right? But this is what one looks like. So typically we see something like this, tags, quantities, type of fan. This has some direct drive upblast, some inline centrifugals, direct drive centrifugals, your makes and models, your CFM, inches of water column, brake horsepower, right? Everyone put brake horsepower on their schedules. Zones, voltage, horsepower, installed horsepower, then FEI. Okay, that's what's different here. FEI values, those are some good ones. Suggested notes, motor should be EC type. Do you guys typically specify the motor type? EC or induction, okay. VFD, of course, if you need it. Curb, fan shall meet or exceed the FEI values and be licensed to bear the AMCA seal, yada, yada, yada. So yes?
Looks like you're going to get to it. Go ahead. I was going to ask if the fourth one doesn't have an FEI.
Oh, who can answer that?
It's under 1 horsepower.
Yeah. You guys are smarter than me. I had to look at it for a while and I'm like, oh, it's under 1 horsepower. So good question. Okay.
Should be a 3-core horse anyway. Way too close to the brake horsepower. Pretty confident your static pressure count.
Yeah, so I actually have a frequently asked questions slide after this, and it's if you up the horsepower, it actually affects the FEI calculation. But I'm with you, I would not select one that close if I didn't have to, because there's no...
It affects it in what way?
Negatively.
Negatively.
Yeah, and I don't really understand how. I think because the motor is further away from where it's operating.
I think
If it's too oversized.
I think a bigger nominal horsepower motor will still hold a few more electrons as it were at the same brake horsepower, just because it's a bigger motor size. I don't think it affected much, but it would use a little more, even at the brake horsepower.
Yeah, be curious to see. I tried to run some selections on it, but I ran out of time. But there is a rule about how much you can upsize a fan anyway? Does that live in ASHRAE 91? 90.1? Okay. So there's already some kind of guidelines to, if you need 2 horsepower, you're not supposed to put a 10 in there or whatever. Got it. But you can go up a size typically. That's what I understand.
If it's within, if the next motor size up is within a certain percentage of the brake horsepower, then you go 2 sides of
Got it.
it. So
If it's right on the edge.
within that percentage of the half horsepower, you'd be within that, it's like 30% or something like that, I think. So you'd be allowed to go.
Yeah.
Probably wouldn't be able to open one.
Right. That's good. It's good conversation. Okay. Questions on that? What time we got, Gina?
It is actually 11:40. When's your cutoff?
All right, I could talk for 5 minutes. I got some stuff here.
I assume the FEI takes into account a speed controller if one was provided with it.
Yes, that's what it showed on that slide. Yep.
That has speed control. It is taking into account the duty point that you have selected versus how much energy it's not using by being able to reduce its speed. Right, to hit your duty point, to operate at the duty point you specify, is that, the reason I'm asking is because like on the pump side,
Uh-huh.
if they take into account if you furnish this pump with a speed controller, you will have because it's the inverse, if there's no VFD from the pump manufacturer, regardless of whether you're putting a VFD on it in the field, you will not be able to get a selection that's lower than like 0.9.
Mm-hmm.
Most selections are 0.95, 0.94, but if you order that pump with a VFD from the pump manufacturer or with a permanent magnet motor with built-in speed control, your PDI is at 0.4, 0.5, way
Automatically.
And I don't know if the fan people do the same thing.
I'll have to look at that. I'm not sure.
Whether it's, obviously you can adjust speed if it's belt driven, but
This AMCA guide
yeah.
shows how they calculate the baseline.
Which is probably based around a fan and
It's based on what we showed earlier, the belt drive, the 4 poles.
Tony, what you're saying that the sticker that it will come with that is going to be the FEI at that duty point, whereas
Yes.
if you add in extra static or whatever and change that,
Yeah.
you're technically out of that FEI.
Correct.
Right.
Correct. That's why it's important to select one so if it changes a little bit, it doesn't kick you out into another FEI.
Not necessarily though, then you're plugging in external duct static and all that. That doesn't, the FEI is calculated for the fan, not what happens beyond the fan.
Right. So it's not at a certain duty point of external at all.
So it's whatever the operating is for that fan that's designed around, it'll be that.
Right.
Whatever the condition is given, if the condition changes, the FEI it's not going to change and say, okay, it's going to be this.
Right.
Because we don't know what that is.
Right. Okay.
So what Tim was explaining to us earlier is if it's selected at a certain FEI, CFM and duty point, and that changes in the field, that the T&B guys will be measuring that and checking the fan curve to see if it still complies with that FEI. How that's actually going to happen in reality, I'm not sure.
But they're not going to go back and calculate that FEI.
Okay. Okay. So, got a few more minutes here. Does anyone know the name of who invented brake horsepower? Came up with it? Horsepower? James Watt. Did you know that's where watts come from? You did? I didn't know that. Anyway, useless information, but I thought it was interesting. So, where could you find more information? Okay. This isn't working. Let me fix this real quick. Display settings. Okay, sorry about that. So if you want to find more information about FEI codes and regulations, energycodes.gov. How will the DOE enforce FEI requirements? Violations can be reported here. Any snitches in here? Snitches get stitches, remember that? I know the engineering community will get you. What affects the FEI calculation? Anything between incoming power and outgoing air power affects the FEI value. This includes fan odor. We already talked about all that. Why doesn't your favorite selection program show FEI values? Because it's probably less than 1 brake horsepower. Should always pick the fan with the best FEI. Anyone? No. It doesn't necessarily mean it's the best selection. Here's an example of that. So we'll finish up with this one slide. How about that? So the first column there is relative cost. Okay. Operating cost per year. CFM. So I selected a 4,000 CFM fan, and the reason the top one's at a different value is because it's a direct drive fan and there's no drive on it. Okay. Different fan speeds. They're all direct drive. You can see the FEI value there. 1.19, 1.29, 1.26, and 1.22. And here's the 3 fan curves for that. So anyone want to guess? Anyone want to talk about which one they would select and why? You know, I like this one here. It's further away from the curve. But how is it on efficiency? 2 versus 3. Pretty close, right? This one's a little more efficient because it's in that better area of the curve. Anyone comfortable with this selection? I would not be very comfortable with that because it's right near the system curve. You start adding some static, you're going to get over to here. You know, and then you can look at the sound. They're all pretty close. And then number 4 is another one, which is pretty close here, right? So who votes for number 2? Nobody? Who votes for number 3? Okay. I like number 3. There's no right answer. Unless there's no wrong answer unless you picked 1 or 4. Those are wrong. All right, any questions? How was that? Was that helpful?
Oh, yeah.
Okay, got it? Okay, so did everybody sign in? Everybody sign in? Gina's got your certificates, so just put in your names there. And again, please go get your signatures, see the vendors, and enter to win the raffle. We'd greatly appreciate it if you spent a little time with the vendors out there. So, great, thank you all very much.